What happens when humanity's greatest achievement becomes one man's fight for survival? Millions of kilometers away from Earth, a place where no human should be left alone, an astronaut waits up with no rescue coming, and only science, intelligence, and determination standing between him and death.
It really is the ultimate test. The safety nets we rely on every single second of our lives, like air, pressure, a functioning biosphere, they are just gone, stripped away entirely.
Welcome to Beyond the Plot, where unforgettable stories come to life. Today we are exploring The Martian, a survival story where human ingenuity becomes the ultimate weapon. Our mission on this deep dive is to immerse you completely in the timeline of the Ares III mission. We are going to blend the raw, emotional terror of absolute isolation with the brilliant, factual science of survival. We are looking at a narrative that strips everything away until all that is left is the human will to live.
I think what makes this particular journey so deeply resonant is the nature of the antagonist. In most space stories, the crew is fighting a rogue AI or an alien civilization or some shadowy corporate conspiracy. But here, the villain is just physics. It is chemistry. The antagonist is the unforgiving, indifferent reality of a dead planet.
And that indifference is terrifying. Let us start at the beginning with the Ares III mission. Humanity has finally pulled it off. We've established a temporary research base on the Red Planet and introduced the crew naturally. They are this tightly knit family of explorers. Commander Melissa Lewis is leading the charge alongside Rick Martinez, Alex Vogel, Beth Johansson, Chris Beck, and our central figure, Mark Watney. They are out there collecting samples, running experiments, making history. It really feels like the pinnacle of human achievement.
Before things go wrong, we really have to appreciate the psychological profile of a crew like this. I mean, you do not just put 6 smart people in a tin can and fire them into space. NASA and international space agencies run these intense isolation experiments, things like the HIC's habitat in Hawaii or overwintering teams in Antarctica.
Right, to see if they break.
Exactly. They are looking for absolute cohesion. You eat, sleep, and breathe with these people. Your life literally depends on the person floating next to you. So the bond between Lewis, Watney, and the rest of the crew isn't just professional, it is a meticulously engineered family unit.
Which makes the inciting incident so devastating. They are 18 souls, which are Martian days, into their surface mission. And suddenly, mission control reports an incoming dust storm. The wind speeds are off the charts, moving so fast the crew barely has time to react. They're hunkered down in their base, the HAB, but it is threatening to tear apart. Commander Lewis realizes they can't wait it out. She orders an immediate evacuation to the Mars Ascent Vehicle, the MAV, which is their rocket off the planet.
I want to pause here because the science of a Martian dust storm is highly misunderstood.
Oh, really?
Yeah, the atmosphere on Mars is incredibly thin. It is about 1% the density of Earth's atmosphere.
Right, so 150-kilometer-per-hour wind on Mars wouldn't feel like a Category 1 hurricane on Earth.
Not at all. Because there is so little atmospheric mass, the dynamic pressure is tiny. 150-kilometer-per-hour wind on Mars would actually feel like a light spring breeze against your spacesuit.
Wait, then why are they evacuating? If it is just a light breeze, why is the MAV in danger?
Well, 2 reasons. First, that light breeze is carrying millions of microscopic particles of sand and rock. It is essentially a massive sandblaster that degrades equipment rapidly. But the fatal threat is the geometry of the MAV itself.
Because it's so tall.
Exactly. The ascent vehicle is a tall, vertical rocket sitting on landing struts. It acts like a giant, rigid sail. Even with low dynamic pressure, if that wind catches the hull at the wrong angle over a sustained period, it creates a tipping moment. If the center of gravity shifts past the landing struts, the MAV tips over.
And if the rocket falls over, it cannot launch.
Right. The entire crew is permanently trapped. They would all suffocate or starve.
Wow, that completely changes the context of their panic. They aren't running from the wind. They are racing against the rocket's center of gravity. So they throw on their suits, blind and disoriented in the red dust. And tragedy strikes. A piece of flying debris, a satellite dish antenna, rips through the storm, strikes Mark Watney, and knocks him out into the darkness. The impact completely destroys his biomonitor signal.
From a command perspective, a flatline in a catastrophic environment triggers a very specific, grim protocol.
They think he is dead. The MAV is groaning, telemetry says it is tilting past safety margins, and Commander Lewis is screaming into her comms trying to find him. They calculate that with a breached suit in a toxic, low-pressure environment, he could not survive more than a minute.
I always struggle with this moment. If you put yourself in Commander Lewis's shoes, how do you make the call to leave one of your people behind? You make the call because you are a commander, not just a friend. It is the ultimate nightmare of leadership. The orbital mechanics and the physics of the storm are completely indifferent to her grief. If she delays that launch to search for a body, the wind catches the MAV, it tips, and the mission ends with 6 fatalities instead of 1.
So it was just pure math.
Yes. Launching was the only mathematically sound decision. It is a brutal, cold calculus.
The launch is successful. Back on Earth, NASA holds a massive press conference. The NASA director, Teddy Sanders, announces Watney's tragic death. Funerals are held, flags fly at half-mast, and the surviving crew begins a grim, year-long journey home on the Hermes spacecraft. But the irony is staggering, because while millions of people are mourning him, Mark Watney wakes up.
This is the moment the narrative pivots from tragedy to an unprecedented case study in human resilience.
His oxygen alarm is screaming, he is buried in sand, and this is the part that always confused me. You just told me the Martian atmosphere is 1% of Earth's, basically a vacuum. Why didn't his blood instantly boil? How did he survive an open wound on Mars?
It comes down to a physiological threshold called the Armstrong limit. On Earth, water boils at 100 degrees Celsius. But as pressure drops, the boiling point drops.
Okay, I follow.
So if you are exposed to a near vacuum, the boiling point of the fluids in your body drops below your own body temperature. Your blood literally boils in your veins.
Terrifying.
Extremely. But Watney got incredibly, horribly lucky. The antenna bar that impaled his abdomen acted as a plug. Combined with the extreme cold and the immediate pressure drop, his blood rapidly coagulated around the metal, sealing the microscopic gaps. The suit maintained just enough atmospheric pressure inside to keep him above the Armstrong limit.
That is wild. The object that almost killed him becomes the only thing keeping his blood in a liquid state. He drags his battered body back into the hab, pressurizes the airlock, and realizes what he has to do. We get this visceral, gruesome sequence where he performs surgery on himself. He pulls the metal out, cleans the wound, and lacking proper surgical staples, he bends a paperclip to act as a hemostatic tool to close his own flesh.
This is a pivotal moment psychologically.
Why? Just because he survived the immediate physical trauma.
Because it forces him out of shock, pain is incredibly grounding. But the real danger isn't the physical wound. It is what happens after the bleeding stops, the psychological freefall.
Right. He realizes the communications array is destroyed. He is utterly alone on an entire planet. I try to imagine this. It is like waking up in a massive locked bank vault, knowing the air is slowly being siphoned out and the whole world thinks you're already dead. Most people would just beat their fists against the vault door until they passed out. Why didn't Watney just give up right then?
You are touching on the battle between raw fear and methodical intelligence. When you face an insurmountable existential problem, like being stranded 225 million kilometers from home, the human brain gets paralyzed by the macro scale of it. It is too big to process.
So he just ignores the big picture.
Exactly. Watney bypasses that panic loop by breaking the macro problem into micro problems. Step 1, fix my stomach. Step 2, figure out the comms. Step 3, count the food. By giving his brain a highly structured, solvable task, he creates a synthetic dopamine loop of small victories. That structure acts as a shield against existential dread.
That makes a lot of sense. So he tackles the micro problem of food. He takes inventory. The base systems are meant for 31 days. But because the other 5 crew members left early, he calculates he has enough of their leftover rations to last him about 400 days.
Which sounds like a decent runway until you factor in orbital mechanics. Even if Earth knew he was alive at that exact second, spacecraft do not travel in straight lines. They travel in home and transfer orbits, utilizing the alignment of the planets.
Right, you have to wait for the planets to line up.
Precisely. A rescue mission would take years to plan, build, and fly. 400 days of food isn't a survival plan. It is a slightly delayed death sentence. He needs to make more food. Specifically, the Thanksgiving potatoes they brought in vacuum-sealed packages. But he cannot just toss a potato in Martian dirt and wait for it to grow. Mars is sterile. There is no bacterial life, no organic matter. It is just dead, oxidized dust. So he decides to engineer a microbiome from scratch. And his method is, brilliantly disgusting.
It requires biological material. The only biological material available is human waste.
Wait, I have to push back here. Can you actually just mix human feces into dirt and grow food? Doesn't that carry massive pathogen risks?
On Earth, yes. Raw human waste is full of dangerous pathogens. But Watney isn't just smearing it on the dirt. He takes the vacuum-sealed waste bags left by the crew, rehydrates them, and mixes them with Martian soil and Earth soil he brought for
Oh,
experiments.
so he's making a compost.
He is composting it, exactly.
Huh.
By spreading it out and cultivating the existing Earth bacteria, he is kickstarting a closed-loop ecosystem. He acts as the architect of a microscopic biosphere. Okay, so he's got the soil and the fertilizer.
Ah.
But any weekend gardener knows you need water. Potatoes are incredibly thirsty. He calculates he needs hundreds of liters of water, which he does not have. So he turns to 12th grade chemistry. He knows the formula. Burn hydrogen gas with oxygen, and you get H2O.
A simple equation on a chalkboard. A nightmare to execute in a canvas tent on Mars.
Let us break this down, because the sheer mechanics of it blow my mind. To get the hydrogen, he decides to bleed highly volatile rocket fuel, hydrazine, from the MAV's descent stage. He drips it over an iridium catalyst to separate it into nitrogen and hydrogen. Let me stop right there. What actually is an iridium catalyst is the iridium eating the fuel.
Think of a catalyst like a molecular matchmaker. In chemistry, breaking the bonds of a molecule like hydrazine, which is N2H4, usually requires a massive amount of energy, like heat or a spark. A catalyst lowers that required energy.
So it makes it easier to break apart.
Yes. When the hydrazine touches the iridium surface structure forces the nitrogen and hydrogen atoms to let go of each other and separate into gases. The iridium isn't consumed, it just facilitates the breakup.
So now he has a room filling up with hydrogen gas, and he has to introduce oxygen and literally light it on fire to create water.
Correct. And remember, the HAB is a pressurized oxygen environment.
That sounds like a recipe for a bomb. If he is literally creating fire from highly volatile rocket fuel inside a pressurized canvas tent, why doesn't the heat just melt the canvas or blow the whole place up?
The margin for error is essentially zero. It is a stoichiometry problem, which is the precise ratio of molecules. If he lets too much hydrogen accumulate before burning it, a single spark will cause a chain reaction. It is the Hindenburg, but enclosed.
Wow.
He has to wear his spacesuit inside the base, extract oxygen from the ambient air, and burn the hydrogen with the excess carbon dioxide he exhales, keeping the flame tiny and controlled.
I am sweating just thinking about it. He sits there for days watching this tiny flame, knowing a single miscalculation means instant incineration. But it works. The chemistry holds up. Condensation forms on the plastic tarps he rigged up. Water pools on the ground. He has literally created water out of rocket fuel.
That precise, dangerous application of science buys him the most valuable commodity in the universe, time.
On Sol 54, a tiny green potato sprout breaks through the Martian soil. The emotional weight of that little green leaf is incredible. He has secured his food supply. But as incredible as that is, we run into a philosophical wall. If a tree falls in a forest and no one is around to hear it, if you survive on Mars but the entire universe thinks you're dead, does your survival even matter?
That is the terrifying half of the equation. Survival is meaningless without rescue, and rescue requires communication.
Let us shift our perspective to NASA, 225 million kilometers away. There is a satellite planner named Mindy Park. Her job is just to monitor the satellite imagery of the Ares III site, basically tracking how the abandoned equipment degrades. But she spots anomalies. The solar panels are wiped clean. The rovers have moved from where Commander Lewis parked them. It hits her. Someone is moving the rovers.
Imagine the cognitive dissonance. You are looking at a photograph of a graveyard, and you realize someone is mowing the lawn. It is a profound shock of recognizing human agency in a place of total silence.
NASA realizes he is alive. But the celebration turns into a logistical nightmare almost immediately. NASA Director Teddy Sanders and the head of the Mars missions, Vincent Kapoor, look at the timeline. Even if they had a rocket ready to launch today, a resupply mission takes at least 8 months. They have no idea how he's getting food, so they assume he will starve long before they can reach him.
The asymmetry of information here is fascinating. NASA knows Watney is alive, but Watney has no idea that NASA knows. They are both operating in silos, yet they both arrive at the exact same conclusion independently. They must establish contact.
Watney knows his only ticket off the planet is the Ares V MAV, which was already sent ahead of time to a crater 300 kilometers away. He has a rover, but it is basically a high-tech golf cart designed for short trips around the base. It runs on batteries. The Martian nights drop to negative 80 degrees Celsius.
Which is brutally cold.
Right. And if he turns on the electric heater, it drains the battery, and he can only drive a few miles a day. He would freeze before he ever reached the rocket.
To solve the heat problem, he needs a thermal source that does not consume electrical power. And the only thing on Mars that fits that description is highly radioactive.
The RTG, the radioisotope thermal electric generator. This is a massive lump of decaying plutonium-238 that NASA uses to power deep space instruments. From my understanding, the crew took this thing and buried it kilometers away from the base the second they landed because it is essentially a radioactive bomb.
Well, it is not a bomb in the explosive sense, but it is incredibly lethal if unshielded. Deep space probes use them because solar panels are useless once you get past Mars. Sunlight is just too weak out there. The RTG works by converting the immense heat generated by the natural alpha decay of plutonium into electricity.
And Watney digs it up, brushes off the dirt, and puts it in the passenger seat of his rover. He uses the radioactive heat just to keep the cabin warm. The absolute terror of that decision. You are literally riding shotgun with a block of decaying plutonium.
It is a masterclass in extreme risk assessment. The risk of freezing to death on a Martian night is 100% it will happen tonight.
Guaranteed.
Yes. The risk of developing fatal cancer from radiation exposure is a problem for 10 years from now. In survival situations, you always prioritize the immediate physiological threat.
So he has heat. But he does not drive to Ares' Earth. He drives out into the desolate expanse of Mars to find a ghost. The 1997 Pathfinder probe, a relic of ancient space history that died decades ago. He digs it out of the sand, hauls it back to his hab, and powers it up. Back at the Jet Propulsion Laboratory on Earth, NASA realizes what he is doing. They literally go down to their museum archives and pull out the exact replica of Pathfinder. The probe wakes up, the camera pivots, and NASA gets a visual connection.
It is a beautiful thematic moment. Watney's life is being saved by the ingenuity of engineers who built a machine in the 1990s. It is human collaboration echoing across decades.
But it is just a rotating camera. He sets up signs around the camera so NASA can point to letters. But he realizes he cannot just put up the 26 letters of the alphabet. He decides to use hexadecimal code, base 16. Okay, hold on. I barely survived base 10 math in high school. What actually is base 16, and why couldn't he just use the alphabet?
Let us visualize the problem. The Pathfinder camera rotates in a 360-degree circle. If you try to fit 26 letters plus punctuation in a circle around it, each card gets a very tiny slice of that pie, maybe a few degrees. From a distance, it would be impossible to tell if the camera is pointing at the letter M or the letter N. The margin of error is too small.
Okay, that makes sense. So how does base 16 fix that?
Hexadecimal, or base 16, uses 16 characters, the numbers 0 through 9 and the letters A through F. That means you only need 16 cards in the circle, giving each card a much wider, unmistakable slice of the pie. In computing, standard ASCII characters, like the alphabet, are represented by 8-bit bytes. A byte can be split into two 4-bit nibbles. Each nibble corresponds exactly to one hexadecimal character.
So NASA points the camera at a number, then a letter, and that pair of characters translates into one letter of the English alphabet.
Exactly. It is a tedious, painstaking way to communicate, but it eliminates the mechanical error of the camera. It is the universal language of problem-solving logic.
The camera moves. It points. Watney translates the pairs. The first message from Earth, "How are you?" Imagine the psychological weight of those three words after months of deafening silence. NASA then uses this primitive system to send in the code needed to hack his rover's software. Suddenly, they are texting each other directly on the rover's screens.
He is no longer a solitary castaway. He becomes a node in a planet-wide problem-solving network.
With communication restored, NASA finally tells the Ares III crew on the Hermes spacecraft that Mark is alive. The guilt that Commander Lewis has been carrying lifts slightly. NASA is building a massive supply probe to drop food to him. Hope is completely restored. Everything feels like it is going to work out.
But again, the antagonist is physics, and physics does not care about hope. Entropy always collects its due.
It is Sol 119. Watney's in a routine. He is harvesting his potatoes, eating the small ones, replanting the eyes. He walks through the airlock, which is this canvas tunnel connecting the hab to the outside. But what he hasn't accounted for is material fatigue.
This is a silent killer in engineering.
What exactly is material fatigue in this context?
Think of taking a metal paper clip and bending it back and forth. You are not applying enough force to snap it instantly, but every time you bend it, the microstructure of the metal weakens.
Until it just breaks.
Eventually, it just snaps with almost no pressure. The hab's airlock is made of composite fabric. Every single time Watney pressurizes and depressurizes that airlock to go outside, the canvas expands and contracts. It stretches. Over 119 sols, far past its intended design life, the fabric simply tires out.
The hab tears. It is a catastrophic, explosive decompression. The airlock blows completely off the hab, launching Watney out onto the Martian surface. His suit saves him from the blast, but when he turns around, it is a nightmare. The hab had burst wide open, the artificial atmosphere instantly rushed out, the temperature plummeted to sub-zero in seconds.
The true tragedy here isn't structural, it is biological.
The potato farm. The beautiful closed-loop ecosystem he built with his own hands is instantly flash frozen. The crops are dead. Every single microscopic bacteria in the soil is dead. The oxygen level plummets to near zero, forcing Watney to patch his suit and the hab with simple duct tape and spare canvas.
The psychological whiplash is almost incalculable. You have fought, clawed, and engineered your way out of starvation. You did the impossible. And in a fraction of a second, a microscopic tearing of fabric erases months of brilliant work.
His math is completely broken again. The food will absolutely not last the 700 days until a rescue ship arrives. He is forced onto starvation rations. He divides a single half meal into 3 tiny portions. We are watching a man slowly waste away.
And this is where we really examine resilience. How do you process that level of arbitrary destruction? He doesn't stoically ignore it. He allows himself to feel the grief. He smashes things. He screams in his freezing base. But the key is, after he processes the despair, he picks up the duct tape. He patches the hole.
But Earth is panicking. NASA knows he is starving. In their desperation, they bypass standard aerospace safety protocols to rush a billion-dollar supply probe onto the launch pad. They skip the final inspections to save time.
A catastrophic mistake. In aerospace engineering, inspections aren't bureaucratic red tape. Rockets endure violent physical forces like vibration harmonics, extreme acoustic loads, structural liquefaction.
It's just shaking itself apart.
Exactly. If a single bolt is torqued incorrectly, the vibration of the launch will shake the vehicle apart.
And that is exactly what happens. Because they skip the inspections, the probe experiences a harmonic resonance failure. It explodes in the upper atmosphere. $1 billion, and Mark's only chance at survival reduced to ashes. It is Sol 186. Watney gets the text on his rover. The probe failed.
Yeah.
There is no backup probe. He is staring death in the face, and there is no clever 12th grade chemistry trick that can rebuild an exploded rocket on Earth.
When standard procedures fail and the safety nets burn up in the atmosphere, rescuing him requires throwing out the rulebook entirely. It requires international cooperation that supersedes politics.
The global space community steps in. The CNSA, the China National Space Administration, has a classified, highly powerful booster missile called the Taiyang Shen. They offer it to NASA. They set aside geopolitical secrecy for the life of one astronaut. But even with this massive rocket, sending a probe directly to Mars will take too long. Watney will starve before it lands.
They need a faster delivery vehicle. They need something already moving.
Enter Rich Purnell, an astrodynamics number cruncher at NASA. He pitches a maneuver that is so mathematically audacious it borders on lunacy. The Purnell maneuver. He says, instead of sending a new probe, we use the Hermes spacecraft, which is currently flying back to Earth with the surviving Ares III crew. We launch the Chinese booster to rendezvous with Hermes as it flies past Earth, dropping off supplies. Then, Hermes uses Earth's gravity to slingshot around the planet, double its speed, and slingshot all the way back to Mars.
The gravity assist, or slingshot maneuver?
I always picture this like a kid on a skateboard grabbing onto the bumper of a passing semi-truck. You let the truck's massive momentum drag you forward, and when you let go, you launch yourself forward at a much faster speed than you could ever pedal. Is that accurate?
It is a great visual, though the mechanism is a bit more elegant. A spacecraft doesn't physically grab the planet. It flies into the planet's gravitational well behind the planet's orbital path. As it falls toward the planet, it accelerates.
It's falling towards it.
Yes, but because the planet itself is moving through space around the sun, the spacecraft essentially steals a minuscule fraction of the planet's orbital momentum. It leaves the planet's gravity moving significantly faster than when it entered. NASA has used this for decades. The Voyager probes use gravity assists from Jupiter and Saturn to leave the solar system.
But this completely shifts the moral weight of the story. It is no longer about launching a care package. It means asking the Hermes crew to turn around. NASA Director Teddy Sanders immediately vetoes the idea. He refuses to risk 6 lives for 1. The maneuver will add 500 days to their journey in a ship that is already showing wear and tear. But the crew? Well, they find out about the math.
The mutiny.
Commander Lewis looks at her crew. They know the risks. But they also know they are the ones who left him behind. They eagerly agree to do it. They hack the ship's override codes, forcing NASA's hand. I have to ask, objectively, is it logical to risk 6 lives to save one?
From a pure utilitarian perspective, no. Sanders is technically correct. The math favors preserving the 6. But human beings aren't purely utilitarian. We have a deeply ingrained evolutionary instinct to rescue our own, to protect the isolated members of our tribe. The decision of the Hermes crew highlights that survival isn't just an individual triumph, it is a collective interpersonal imperative.
They execute the maneuver. The Chinese booster launches the supplies, Hermes catches them perfectly, swings around Earth, and hurtles back toward Mars. The rescue is officially on. But the tension doesn't drop, because Hermes isn't landing on Mars. They are just performing a high-speed flyby. Watney still has to get off the planet to meet them in space.
And his vehicle is entirely unsuited for a high-velocity intercept.
We jump to Sol 461. Watney is gaunt, exhausted, practically starving. He packs up his rover and leaves the hab forever. He drives tens of thousands of kilometers across the harsh, freezing, cratered Martian landscape, finally arriving at the Ares the MAV on Sol 538. The rocket is there. But there's a huge problem. NASA tells him the MAV was only designed to reach low Mars orbit to meet a stationary ship. Hermes is flying by at an incredible speed. To catch them, the MAV has to go much higher and much faster.
Which brings us to the tyranny of the rocket equation.
Tsiolkovsky's rocket equation, right?
Yes. Simply put, mass requires energy to accelerate. If you have a fixed amount of fuel energy, the only way to increase your final speed is to decrease your mass. You have to lighten the ship.
And NASA's solution to lighten the ship is madness. Vincent Kapoor suggests this insane plan. They tell him to rip out the life support systems, rip out the secondary control panels, take out the windows, and then take off the nose cone. They tell him to cover the open top of the rocket with nothing but a canvas tarpaulin. You are taking a spaceship and turning it into a convertible.
It is the aerodynamic equivalent of driving a convertible into a Category 5 hurricane at Mach 5. The drag forces, the vibration, the lack of structural integrity, it is deeply terrifying. But physics demands a lower mass fraction. It is the only way the math works.
It is Sol 560. Watney eats his very last meal. He says goodbye to his hab, and he straps into this stripped-down makeshift rocket chair he launches. Without the heavy nose cone, the aerodynamics are completely ruined. The ship shudders violently. The G-forces are so brutal they literally crush him into his seat, and he blacks out as the makeshift rocket violently accelerates.
And keep in mind the communications delay. Because of the distance between Earth and Mars, NASA is watching the telemetry with a helpless 12-minute delay. They just have to watch the numbers flicker on a screen and pray the canvas holds.
Watney regains consciousness in orbit, but the intercept is off. The spacecrafts reach the estimated height, but their relative speed is mismatched. The MAV is moving 42 meters per second too fast relative to Hermes. They're going to fly right past each other.
In the vacuum of space, speed and distance are absolute. You cannot just hit the brakes like in a car. There is no friction. If you miss your target by a few meters, you will drift millions of miles into the void. They have minutes to solve a complex orbital rendezvous problem that usually takes supercomputers months to map out.
Commander Lewis makes a desperate decision. She seals the front of the Hermes, and they intentionally blow the atmospheric pressure doors, using the explosion to slow their ship down. They cause a directed explosion of their own ship's atmosphere, venting out into space.
Newton's third law. Every action has an equal and opposite reaction.
Right. The highly pressurized air blows out the front, pushing the massive ship backward, acting as a makeshift thruster. It works, mostly. It slows Hermes down by 12 meters per second. But the distance is still too great. Lewis goes out on an EVA tether, floating in space, reaching out to catch him. But the tether is too short. They are meters apart. Hermes is out of fuel, Lewis is out of rope, and Watney is trapped in his capsule.
But Mark Watney refuses to yield his fate to the void.
Waking up, Watney makes a desperate choice. He looks at his spacesuit glove. He tells Lewis to hold on. He takes a sharp tool and pierces a tiny hole in the palm of his glove. The highly pressurized air inside his suit violently escapes through the hole.
It is the exact same principle as blowing up a balloon and letting it go before you tie it. The escaping air provides thrust.
The Iron Man maneuver. He uses his own life support air as a propellant. He flies out of the MAV capsule, spinning wildly in the blackness, steering with his hand as the air shoots out. He flies toward Lewis. He catches the tether. They clutch each other tightly. And through the static of the comms, exhausted, breathless, having survived impossible odds, Watney can only say, "I'm happy." The 600 days of misery are over. He is finally going home.
It is a breathtaking climax. He literally punctured his only protection against the vacuum of space, using the very air he needs to breathe as the propellant to bridge the final gap between isolation and humanity. It perfectly encapsulates his entire journey.
It really does. I get completely swept up in the cinematic tension every time, noting how every single thing that could go wrong did, and how they literally blew up their own ship and punctured a spacesuit just to close a gap of a few meters. Which brings us to the final part of our deep dive today. Let us look beyond the plot at the story as a whole. Mark Watney isn't just a survivor. He becomes a symbol of human adaptability. He didn't survive with a laser gun or by fighting aliens. He survived with a potato, a roll of duct tape, and an incredible power of humor in the face of despair.
Humor was his most critical psychological defense mechanism. It kept him grounded. But on a broader scale, this narrative revolutionized modern science fiction. For decades, traditional space stories relied on unknown threats, monsters, or space madness. This story proves that we don't need fictional monsters. Human creativity, cooperation, and the battle against raw scientific reality can be just as thrilling, if not more so.
It makes you look at everyday objects with entirely new respect. A potato, a roll of duct tape, and human waste. You just see them differently. The whole story is an absolute love letter to human curiosity and the scientific method.
And that is the core takeaway. Science isn't just cold math written on a chalkboard. It is the tool we use to express our most profound human desires, the desire to live, the desire to explore, and the instinct to protect one another.
It shows that when push comes to shove, humanity will move heaven and earth and Mars to save one of our own.
As you think about Watney's journey, consider this final thought to mull over. The next time you look up at the night sky, realize that the vast, deadly emptiness between the stars isn't a barrier, it's a puzzle. And as the story shows, there is no puzzle that human ingenuity, a bit of duct tape, and the collective will of a species cannot solve.
You've been listening to Beyond the Plot. If you enjoyed this journey through science fiction and survival, leave a like and subscribe for more unforgettable stories. Until next time, go beyond the plot.